get started, I'd like to thank everyone who's joining us today. Welcome to today's CNCF webinar. It's going to be on the Intro to Virtual Kubelet 1.0. I'm Karen Chu. I'm a CNCF ambassador and community manager at Microsoft, and I'll be moderating today's webinar. We'd like to welcome our presenter today, Ria Bhatia, Virtual Kubelet core maintainer and program manager at Microsoft. Just a few housekeeping items to go over before we get started. During the webinar, you will not be able to talk as an attendee. There's a Q&A box at the bottom of your screen. Please feel free to use that to drop your questions, and we'll get through as many as we can. The session is being recorded and will be sent out after with a link to the presentation. And with that, I will hand it off to Ria to start today's presentation.
Cool. Thanks, Karen. I'm really excited to be here and talk about Virtual Kubelet 1.0 and the intro to Virtual Kubelet. So I hope a lot of you don't know what Virtual Kubelet is, because we're going to start from the beginning and level up all the way towards use cases that a lot of our partners are working on. So let's get started. And the introduction to me a little bit more in depth. Yeah, I'm a program manager at Azure Compute and core maintainer of Virtual Kubelet, and I basically work on kind of up and coming projects that us in Azure are working on, but then also us as a community are starting to work on. So it's an exciting space, and I was really plugged into the serverless kind of space in the past year and a half. So it's been fun. All right, let's see. Okay, so I'm excited to say that Virtual Kubelet is part of the CNCF as a sandbox project. This probably happened 8 months ago. It was a long time ago. But we are really happy to have the support of the CNCF and excited to hopefully level up to incubating in the next couple of months. So we're gathering case studies right now, and we're starting to start that process. Okay, Virtual Kubelet itself. So what is it? We've basically masked what an actual node is in Kubernetes with this thing called Virtual Kubelet. So if you don't know what a kubelet is, the kubelet will register all the components of what a node is. So like, for example, capacity and what kind of OS it is and things like that. So, and it also houses like the kube proxy for networking and yeah. So we've basically made all those registrations with this Virtual Kubelet so you can connect up your own APIs to Kubernetes APIs. It's just an interface. Excuse me, my allergies. But it's just an interface into Kubernetes. So if you start to think about the use cases, what if you wanted to connect this Virtual Kubelet into, I don't know, maybe your car? You could actually do that as long as you understand what it means to create a pod, delete a pod, and possibly update a pod in the future. You could technically allow Kubernetes to create a pod in Virtual Kubelet and possibly start your car. So that's kind of the level of abstraction we're talking about. We've just built this interface and we've open sourced it for anyone and everyone to go and build their own providers for how they want to extend Kubernetes. So it really creates Kubernetes as a common control plane for really any kind of workload. So the only thing kind of binding all this together is the Kubernetes API. Okay, a little bit more in depth. Sorry, this is super wordy, but you can just listen to me or read the slide, either one. So Virtual Kubelet creates the concept of pods and nodes in the abstract. So they're not actually housed in your cluster. When you go and create a pod, you'll see the pods in your cluster. You'll see those extra Virtual Kubelet nodes in your cluster, but they might actually not be physically in your cluster. They could be if someone decided to create that. That's actually just the kubelet. But in reality, they're running somewhere else, whether it's in a car, in a different data center, in a different cloud, possibly on a satellite in outer space. So it could really be anywhere. Today, when we think about nodes, it is a bounded resource. So you have to have some sort of memory capacity to it or compute capacity, some amount of cores. Virtual Kubelet actually allows you to have an infinite pool of capacity because we don't bound you. So our project itself, we allow you as a provider, someone that wants to connect your own APIs to Kubernetes, to choose that boundary. So if you are a cloud provider, for example, you could choose the boundary of what your data center is. I mean, that would probably be bad because then you would have your customers understanding the bounds of your data center's capacity, and they could technically take it down. if you allow that much compute to be spun out at the same time. But otherwise, technically to a customer, if you give it an unbounded resource, like they can start to really spin out resources without having to provision more nodes, which is interesting. It'll all look like it's sitting in that one virtual kubelet node, but in reality, they could be containers spread across nodes across multiple data centers if the cloud provider chose that. And a pod is a set of containers running within a sandbox. So we have, if you do that kind of model and you have just a container kind of represented as a pod in this sense, technically it could be multi-tenant. So each pod could be given to a user and you would have a sense of like hard multi-tenancy in that mindset. So that's just something to think about, instead of the pod sharing, a bunch of pods sharing resources on a node. So yeah, the specifics of how all of these capacity things and networking things and like config maps and secrets, they're all described by the actual provider itself. The common code in VK, our interface is actually really small and simple. As a PM, I'm able to go in and understand what our interface is and what exactly we're doing all the time, because of course, like I'm not in code every day. But it's also easy for our providers to go in and understand what they need to do to plug into our interface. So really, if you can just create a pod, delete a pod, you have mechanisms for config maps, possibly, or secrets, you can be a provider with Virtual Kubelet. And VK itself can actually be deployed as a pod. So you can use some Helm charts and you can deploy it. It's just a deployment. So technically, you could have it running in a node in your cluster, and then that Virtual Kubelet will work with whatever APIs that you've called out to create pods that are not in your cluster. So this is our repo. This was a screenshot taken a long time ago. We have about 1,000 more stars now. Fun popularity contest. But we've done a lot of work in this repo. So we actually have a community repo now that we just spun out for the 1.0 release. We have milestones. If you go into issues and click on milestones, we are working towards a couple milestones. We're finishing a couple issues that we had for the 1.0 release. We want to make sure it's perfect. But basically, like, this is your home if you want to create a provider. You would click in providers, and then when you click into that, and I can show you the repo at the end, you'll see a list of all the providers that are currently supporting Virtual Kubelet. And you can also get into their READMEs and figure out how to deploy these providers. So that's really useful. A lot of them are just Helm charts that you go and deploy, but you do have to usually have some like customer configuration to be able to be allowed to spin out to maybe a different cloud or something like that. So that's something to keep in mind. But providers is that folder that you want to go and look into. Okay, so our provider definition, kind of the same things that I've been saying. You need to be able to provide the backend plumbing necessary to provide the lifecycle of a pod through Kubernetes, and supporting what it means to be a resource in Kubernetes. So Kubernetes needs to look at Virtual Kubelet and understand that they can spin out workloads to Virtual Kubelet. And we do that in a couple different ways. One is that we use taints and tolerations. So we basically have tainted the node, and it's basically a lock on the node. So every workload has to have a toleration to be able to tolerate that node and be able to be spun out to that node. We in Azure have explicitly done it. Providers can do it differently, whether they decide to taint the nodes or not, just because it's a different billing model. We don't want people to accidentally get spun out into Virtual Kubelet because there are some limitations. For example, a limitation would be you can't do daemon sets. You don't have access to the actual node host itself. So some of the container monitoring solutions won't work because they actually go into the host itself, into Heapster, and they gather the node metrics, where in Virtual Kubelet, you can't exactly do that. There are some workarounds that we've worked on to work around it, but that's kind of the context. It is a little bit different from a node because we aren't exactly a node. You need to conform to the current APIs specified by Virtual Kubelet. And then you can't have direct access to the Kubernetes API. So you need to understand how to get data like secrets or config maps or things like that. So that's what it means to be a provider. All right, so how do we do it? A little bit of the history, because I think it's pretty important for an early stage project. We started probably back in 2017, I want to say. It's when I joined Microsoft, actually. And Brendan Burns had created this project called the ACI Connector, which is the Azure Container Instances Connector. And so in Azure, and actually a lot of other companies like Alibaba and Amazon have created very similar things. And so they're all kind of the same thing. We've all created a way to spin up containers on the fly, whether you have to provision a cluster first to get those containers and get that interface. In ACI, you don't have to, you just get containers. So we were thinking about how do you get all of the functionality that you get at Kubernetes, but abstract away the nodes? Because we didn't want to build in another distributed system. We didn't want to build in how to auto scale or how to do load balancing or service discovery or anything like that. Kubernetes already does that for you. So to just abstract away more infrastructure, we just decided to connect the two. And the way we did it was by kind of hacking the kubelet itself. And it turned out to be pretty easy to write. And from there, we kind of realized that this might be something that other people wanted to do. So we made it pluggable and open. And that's when we just stripped out everything that was Azure. We made an interface. We partnered with HyperSH. We partnered with Amazon and VMware and a bunch of other companies who were also thinking around the same things of like, what is serverless Kubernetes and what does it mean to have a pods as a service or a containers as a service? So us together brought it to the market. We released Virtual Kubelet at KubeCon 2018, I think, in Austin. And it was awesome to see the community engagement and to see everyone really excited. And from there, we decided to start community meetings every week or every other week. We have a Slack channel in Virtual Kubelet. And our jobs as core maintainers are really to make sure the process is as easy as possible to onboard any providers. So we don't care who you are, we will help you onboard. And not only that, we'll also help the users of your guys' providers make sure they have solutions, because we get a lot of issues from providers if something's broken. And so we're always trying to keep track of like the health of the project overall and all of our providers. Here are a couple tweets. So some of you might know Jessie. She also was one of our first contributors. She actually helped build the interface with Eric St. Martin, which is pretty awesome. Brendan, of course, has always been there for this project. And then Amazon was pretty excited about Virtual Kubelet. They connected Fargate to VK. And then a couple of our customers. So WebJet, for example, was really excited to see ACI happen and ACI plus Virtual Kubelet happen. And a lot of people were just kind of looking at the space and thinking about what they could do. And it's always really exciting to talk to people about their different use cases, because like we've heard everything from like, I want to create a provider to spin out to Domino's, for example, or I want to create a provider to spin out to a satellite like close to the moon. So even if you aren't a cloud provider per se, you can use Virtual Kubelet to kind of have this common and easy control plane that is Kubernetes that we all know. And it's kind of easier for operators to understand how to spin out to different kind of workload types now. All right, so this is what the Kubelet does today. Here are the asynchronous and synchronous kind of control loops that we have, and the things that we're polling for inside the kubelet itself. So we're always getting node stats and pod stats and container logs and things like that. And then you also have to create, update, and delete your pods, volumes, and secrets. So this is kind of what our MVP strove to be. We wanted to be able to create pods and secrets and do the DNS routing. I think the only thing we haven't specifically nailed in this is actually volume changes, but everything else we have, which is pretty exciting. So we have exec, or at least we have it in a PR. We have container logs. We pull for these logs and stats and things. So that's pretty exciting that we're almost at like what we said we would do about a year ago. And some things just don't make sense. So for example, volumes, it's very provider specific. So we haven't really gotten a provider that's ready to mount volumes close to their containers. I mean, we do volumes in our own clouds like Azure Files and things like that, but we don't have like disk support or PVC support, for example, because that just doesn't make sense yet. Okay, so challenges when creating a provider. There are a lot of design decisions and a lot of engineering decisions that are now delegated to you. And all of us have gone through the same process of being a provider and getting to like a production ready service. Private networking is hard because you now have to replicate what it means to be kubeproxy per container. So I know Alibaba and us have done it. I think Fargate might have done it too. But we basically now deploy a sidecar per container instance, per container spinning up through Virtual Kubelet to be able to get service discovery, basically, and be able to create services. That's how we've hacked it. So instead of one kubeproxy per node per kubelet, we're doing it per pod. So what should a max node resource be? This is something that we've thought of so many times. And how do we expose it? Is it important to a customer? Some customers want to spin out to 100K containers, right? But each container itself has its own resource, and then the node resource, like, should it match the amount of containers that you need, or should it match the amount of compute that you have in your data center, or should it match like the amount of compute that that customer has is allowed to spin out to for that subscription? So that's a lot, and that's why this is a complicated question. And we've continued to make it open-ended for our providers. What version is VK? So we have also hacked so whenever you create a node in Kubernetes, you get a version tag with it. So when you get nodes, you'll see the Kubernetes version of your nodes. Virtual Kubelet does not go off Kubernetes versions. We're always tracking kind of what the kubelet's doing, but we don't really need to so much. So we basically go off the version when the other nodes were created, plus we add our own VK tag sometimes. So usually, like, the most important thing is we add our own VK tags so you can see the actual Virtual Kubelet version you're running, and that's the most important thing. And then how do we enable customers to monitor their pods? Because the only way we've really hacked through this is we have to aggregate the container metrics from every container itself. We can't aggregate it through a node. So that's something to keep in mind. So that we've gone through challenges, these are all the things that you can spin out to. So you can spin out to HashiCorp, you can spin out to like their Nomad provider, Fargate, to Domino's, to DCOS, to IoT Edge and Azure, to Azure Container Instances in Azure. People have made providers for almost everything. I know vSphere and like Vic also has a provider and things like that. So. And sometimes, yeah, you just need to run a container. So that was the premise of what why a lot of us decided to create providers for Virtual Kubelet. We just wanted to create containers in Kubernetes and not have to manage node infrastructure anymore. We didn't want to have a node go down and then all of the workloads on that node go down at the same time. We just wanted to deal with the container runtime. So here's a diagram of what we did in Azure. It's very similar to some of the other use cases you're about to see. So VMs, this is your cluster of VMs, a control plane. You have something called a virtual node that will spin out unlimited compute to Azure. And if you use this, you'll realize that in Azure, we've actually have limits for you for your subscription for each data center. So that makes it difficult because when you look at Virtual Kubelet, you're like, oh, I have, I don't know, 3 terabytes of memory that I can use. But when you go and actually use it, or like 300 cores or something ridiculous, when you go and actually use it, you're going to get, and if you try and spin out that much, you're going to get hit by limits in Azure. And you're going to have to go through your container logs to realize why that's happening. So that's one example of why this is kind of still difficult for people. We need to figure out a better way to expose metrics through these like limits through the kubelet to make the user experience easier. And this is going to be the same across the board. But an example, like, we decided to use this as like burst compute. So if you have a bunch of nodes and you need to autoscale quickly. So if you're a gaming company and you have all your games are online and you're trying to now spin up compute because you just got a sudden burst and load, and maybe you weren't expecting it, that's when you can use like the HPA and Kubernetes and tasted tolerations and node affinities to basically be able to on-demand spin out to ACI. So you don't have to think about auto-scaling your nodes. You just spin out into this unlimited compute, unlimited. But then after the fact, when your workloads are, when it's kind of done, when there's no more requests coming in, for example, you can burst on custom requests like requests per second. All these instances will spin down and you won't have nodes running when you don't need them to be running. So the cost model is kind of nice because you just pay for what you use. So this is HashiCorp's Nomad provider for VK. And there's actually a video that we did at KubeCon in Barcelona about the Nomad provider. So that's definitely a better explanation. But we basically were able to connect Nomad to Virtual Kubelet. So when you spin out like containers in VK, you'll go into the Nomad portal and you'll see all these Nomad tasks actually come through, which is pretty cool. And there's a really awesome demo that Mishra did. So I would encourage you guys to check out that talk. And then Alibaba's cloud use cases for VK are also really cool. They're doing the same thing that we did with ACI. So they have this thing called Elastic Container Instances in their cloud. And they're basically, their pods can have side containers. So what they've done is they've incorporated what it means to be a kube proxy and kube DNS in their container instance themselves. And then they're spinning out through Virtual Kubelet to their container instances, and they're using Kubernetes as their common control plane. So this is a service that you can go and use, or serverless Kubernetes in Alibaba's cloud today, which is pretty cool. I think they actually had this integration before Azure did too, before anyone did. Us and Amazon were kind of just writing blogs and just doing the open source thing, but Alibaba went full force and deployed this into their service really quickly, which is awesome to see. And another thing we haven't seen so much. So Alibaba is also using Virtual Kubelet internally in their own infrastructure, which is really interesting. So as a cloud provider, they're using VK to scale their own distributed systems and to also have teams have their own clusters. So they don't give each team a cluster in their cloud. They have to be really efficient for the workloads that they run. I mean, if you look at their stats, it's insane. They blow Amazon out of the water for like their most busy days of when they're selling like their stuff online on their market. But basically they give one virtual kubelet per team. And from there, the team has full reign over what they deploy and what they don't, but they only get charged for stuff that they're running, for example. So everyone is basically distributed across an entire cluster. And that means they're really efficient internally because they're all on one cluster, but they still understand that this is my node, I will spin out to this node, and these are all my workloads. And so they kind of just use pods and the node abstraction per team rather than a cluster. And over here in the Americas or other places, like we see a lot of people just doing one cluster per team basically when you're developing, which kind of sucks when you think about the cost efficiency of that, because if you don't have workloads running all the time, you're wasting those resources when another team could be using those resources, those compute resources. So in this case, this is actually probably one of the most efficient designs that I've seen so far. All right, so now for a little video of an example of how you could use Virtual Kubelet if you're a customer. I'm gonna not use this voice and just voice over it. So this is an example of a web app. I'm running it on a Kubernetes cluster. It's basically an app where I can go and buy a bunch of power tools or gardening tools or things like that, which I also need because I am currently killing all of my roommate's plants at my house because she's been gone for a week and they're all dying. So I'm gonna go and check out some stuff, but say it's Black Friday. This website's going to get a lot of load and it needs to make sure that I can spin out to all the customers. So the way that it's doing it is by collecting custom metrics in their cluster using Prometheus. We're basically collecting requests per second, and we've spun out a bunch of load to this, just like test load, to see how we're scaling up. So over here is requests per second for the entire cluster itself. So this entire cluster is it started at 0, and then it's kind of ping-ponging back and forth to almost like about 500 requests per second. And then if you look over here, we're calculating the requests per second per pod. So once we get to 100, we're actually spinning out another pod. So this is what the horizontal pod autoscaler in Kubernetes is doing for us. It's scaling out these pods. Our response time went up. So you don't want your response time to go up. That's the latency it takes for customers to check out. So our response time went up. But as soon as we started autoscaling, it actually pivoted down. And the interesting part is we only have 2 pods running in our cluster that are worker pods that are working through all this load. And we spun out 19 and it actually gets up to about 34. I didn't record all of it, but we spun out a bunch of pods to go so they all can go and help with the act of just taking down the load. And when they're done, they're going to spin back down. So once these requests per second per pod get below a certain number, they're going to slowly spin back down, which is kind of nice. So that's that guy. So one of my last slides, just join us. We have a Virtual Kubelet website, thanks to the CNCF. This is our GitHub. We have a Slack channel in Kubernetes, so reach out to us if you want to be a part of the community. And thank you. And I think now we can take a bunch of questions. We have plenty of time for that, so good.
Cool. Awesome. Thanks for the presentation. And yeah, we'll have some time for questions. So if you have a question that you'd like to ask, please drop it in the Q&A tab at the bottom of your screen, and we'll go through as many as we can.
Give me all the hard ones. Just kidding, not too hard, but.
Okay, so first question is, where does VK reside and where does the code reside?
So VK itself, like are you asking about like if it's in a cluster? I would assume it's that. If you're actually like creating VK, it resides usually on a node. So usually what we do is there's one node running in the cluster, and there's the virtual kubelet pod is running in the cluster, but it's also kind of faking out our node interface, faking out like Kubernetes itself. And it's giving you like this fake node. When you do kubectl get nodes, you'll see the virtual kubelet node, but when you do kubectl get pods and all namespaces, for example, you'll see a virtual kubelet pod. So it actually just is running as a pod in your cluster like any other workload. The code itself is a process within the container. So we're running a process, it's all in Go in a container itself. And if you want to check out the code for every provider, it's all in the Virtual Kubelet repo and the ways to spin out these pods individually. So technically you could spin out all the providers, all the Virtual Kubelet providers in one cluster and have the ability to have a bunch of nodes in your cluster and spin out to all these things, but they all are running their own code. Well, I wouldn't say own code yet, but so before 1.0, all of the binaries were combined. After 1.0, we basically we're splitting everyone out, and every single provider will get their own binary. So
cool,
means,
thanks.
Yeah, no problem.
Next question is, does it already have support for Windows containers?
So technically, Virtual Kubelet as the project, yes, because we have something called an OS type, which you can toggle. So if you want to put Windows or Linux, doesn't matter. The real question is, does it have support for the providers? And that's a different question you can ask to every provider. You can ask Alibaba that, you can ask Amazon that, you can ask us that. I know in Azure we have it. We have support for Windows and Linux. But from a provider perspective, it's actually really easy to just toggle that on and off. The hard part is understanding how you distribute that in the back end. So as a cloud provider, you need to understand those calls coming in and be able to spin out a Windows container in your clusters for the customer, basically. So yes, technically yes, Virtual Kubelet itself does.
Cool. Next question, is there support for this in Azure portal? We have an AKS cluster and would like to try this out in our in our dev environment.
Yes, so in Azure portal, in Azure, it's GA. It's called Virtual Nodes. So if you go into the AKS portal and you create a cluster, you have to be in the right region. We're only deployed, I think, in like 12 regions for this thing. So when you're in the right region, you'll see something called Virtual Nodes and probably the node pools section. You just click that, like check mark it, and then go to the networking page, and you'll see that we're delegating a subnet for you specifically for ACI, and then a subnet for your Kubernetes cluster. So we have 2 different subnets, and every container instance that comes up gets its own private IP. So it is private networking. You can do service discovery, you can do load balancing. It will look and feel like a Kubernetes cluster in and all out, hopefully. So yeah, just go and toggle the virtual nodes thing on. Try like East US or West US or something, or South Central. Those will have it. Northern Europe might have it. Western Europe. Yeah, should be online, the regions.
Cool. There's a question that says, can I run only VK leveraging ACI 0 nodes?
Not yet, no. So we're still specifically talking about Azure, so I'll continue on that. We do not have support for 0 nodes yet. There are a couple other things that are higher priority for Azure and in general, and we're still running Virtual Kubelet on that node. So you still need at least one node in your cluster to be able to run Virtual Kubelet, so not yet, but the best thing you can do is just do a 1 node cluster. That would be as expensive as doing a 3 node cluster, for example.
Cool. Okay, and then this is a question about the roadmap of VK. What exactly is VK going to achieve by transforming as a library?
By transforming as a library? That's an interesting question. Probably better for, honestly, one of the developers on our team, because they're the ones that are spitting it out. But
or can you speak more about like the roadmap for VK?
Yeah, I can speak about that. Specifically for the library, I would definitely go and ask that in our Slack channel. I can give you my best guess. We're basically trying to make VK as efficient as possible and as easy as possible to read and develop in. And I know for a long, long time, we've been wanting to make a library. So if you want very specific reasons, I would definitely reach out to like Brian Goff in the Slack channel, another core maintainer, for why exactly. But the roadmap for VK, so we're actually working with a couple new people that in the community that are working in VK. Actually, one of them is Netflix. They found a lot of cool different bugs and kind of efficiency things that they want to start doing. So, I mean, our goal is to be able to spit out to, like, for example, 100K containers in a couple minutes, for example. So that's kind of the level of efficiency and quickness we're trying to get to. So whatever throttling things that we have in VK, whatever limits us, we're going to be working through that. I know one of the things is that we are currently registering everything as a queue, and we're deleting things as a queue, so we can't do really anything concurrently yet. We can spin out like 10 containers at a time, for example, but we can only really do one thing at a time. So we're trying to make that more dynamic and trying to make that more efficient. So Virtual Kubelet can do multiple things. Another thing is Virtual Kubelet apparently will also freak out if you have a Virtual Kubelet, if you have a name, if you used to have the same name of a container in your cluster, and then now Virtual Kubelet is seeing that same name again, there's some weird behavior that happens. So we're kind of finding all the weird edge cases. We're trying to make it more efficient. It's nothing like big feature sets because we're fairly compliant to what we think users need. It's more like now we're trying to tackle the problem of scale. And that's really what we're working towards. So if you have these high scale workloads, please do some scale testing with VK, find all the weird issues. We will, that's what our next releases are going to be tackling, and probably our 2.0. And yeah.
Cool. So this question is about, can you explain the concept of a provider a little bit more for someone who's new?
Yeah, so a provider is someone that wants to use Virtual Kubelet and wants to use our interface and has their own, they want their own customers to be able to spin out from Kubernetes to their service. So if I was, I want to have a different example. So yeah, I mean, as a cloud provider, a lot of us are trying to figure out how container instances spin out from Kubernetes. But another example is IoT Edge. So if I want to have people use Kubernetes as a common control plane, because the way that people use IoT Edge right now is kind of fragmented, and they could kind of maybe spin out things in multiple different ways, but everyone already knows Kubernetes. So why don't I just allow my IoT Edge devices to look like nodes in Kubernetes? Whenever you deploy a pod or a workload to it, it'll update the actual IoT Edge configuration, for example. So someone did a little workshop and a little demo on this. They connected Virtual Kubelet to an edge device like a light bulb. And then anytime they updated their pod configuration, it would change a different color. So they kind of ran that all through Kubernetes, and another user wouldn't have to understand how to connect up their device to Kubernetes. It'd already be done as a provider. They could just use the provider's code. But then they can now use Kubernetes to update the providers, their IoT Edge devices, for example. So a provider, yeah, and they also, so they want providers in Virtual Kubelet specifically, they want to be housed by us because we kind of give them the support and the life cycles, and we will automatically give them all the changes, the interface and things like that, if they so choose, like within our project. So it's really good for people that have a service and they want their own customers to be able to use a service through Kubernetes. That's the premise of it.
Okay. Next question. Can I run VKs in batches, say front-end containers in VK set 1 and app logic in set 2? I mean, mixing two different containers.
App logic and what? Yeah, so you're basically talking, you want like the containers to be able to talk to each other, I'm guessing is the premise. Like you want to have a back-end container and then a front end, and you want them to be able to communicate and scale up and scale down depending on load. The answer is yes. All you need for that is like service discovery and maybe possibly like private networking if you want it to be private from your cloud provider, that they would deliver that for you. But essentially, yes, we've given the Virtual Kubelet interface all of the things it needs to be able to run real apps. So the example that I showed in the video, I had worker nodes and I also had my logic, like my backend logic in the cluster, but then I had my worker pods in ACI. There are some things that you might not be able to do in ACI, but like you can also talk from the pods in your cluster to your pods in ACI. So if there is a limitation like daemon sets or needing like your host, needing to get back into your host, you could run some of the containers on the nodes themselves and then run like your worker pods and scale, put what you need to scale on ACI. That's usually how we've kind of done that if we found a limitation.
Okay. Next question. From where does Virtual Kubelet get compute and storage resources? I'm assuming cloud, but can they be decoupled? Like, can I have a compute resource from AWS EC2 and storage from Azure?
Technically, yes. We would not block you from that. That's really interesting. That is not something I've ever thought of. So yeah, I mean, all you need to do is reconfigure your own, you would have to create your own provider for that. You could honestly probably copy Amazon's code and whatever else you want for storage into there and create your own mechanisms back in. Well, the thing is about storage is like a lot of the clouds, like I don't know if you can use Azure files, like for example, with a compute resource somewhere else. That would be the question. Like, is the storage in your cloud compatible with the compute in another cloud? As long as they are, or in theory should be, yes. But that's something really interesting. I would try that out and let us know what happens. I don't know exactly because, yeah, it actually should just work because if it's not coupled with the compute, it should just work anyway. So yeah, yes.
Cool. Next question. How resilient is Virtual Kubelet? For example, what happens when the virtual pod becomes temporarily unavailable?
Yeah, so I know we've had issues with this in the past. So today we do save, like we basically, like if the pod for example, becomes unavailable. And when it comes back online, and the only reason that would happen is if your node goes down. So if your node goes down, like Kubernetes will be handling like how pods fail over. So technically, if Kubernetes does it right and moves your pods back, Virtual Kubelet should be able to register back to the cloud provider and understand the containers that it should have. We're actually working towards this in 2.0, where we're trying to get closer to a model of how the kubelet does it. So the kubelet kind of always has this understanding of what pods it has internally, while Virtual Kubelet's always checking back. So we're always checking the cloud provider and checking like our list of pods versus like what the cloud provider is saying when we say like get pods from like this kind of resource. We're always checking back and forth and finding the differences. We've also made that more efficient in 1.0, but we're trying to get closer to a model where like in VK, you basically don't have to like find those differences. You can just understand that you are yourself the kind of the knowledge of the information you are holding the same kinds of pods as the kubelet would. How we do that is kind of a question. But if it does go offline, all your workloads should stay there. There might be some edge cases where things get lost. We've had this, this was a long time ago, but we would have these ghost resources kind of spin up. So you delete a pod, but it would look like it was there. So if that happens too, just like put up an issue. That should be long gone. But a lot of these things also can be up to the provider. Some things might be wrong in the provider using itself and not Virtual Kubelet. So it's definitely like an interesting partnership that we have to have between the providers and Virtual Kubelet to make sure we're showing the right things. But yeah, so we're making it more resilient. I would say today, yeah, like we should be resilient enough for like what the Kubernetes standards are for failovers and things. So
cool. Next question. Is it possible to have 2 containers in Virtual Kubelet within POD pods in a sidecar pattern? The demo looks like it's running multiple single containers in Virtual Kubelet.
Yeah, so the demo that I had was running multiple single containers. If you look at the pod itself, every single pod that was set up in ACI had a kubeproxy sidecar already and a monitoring sidecar. So we were spitting those out as we do that as a service already for you, so you don't have to see it. You don't see what's in you don't have to see what's in your pod. And other cloud providers are doing the same thing, like Alibaba is doing the same thing for their customers. But yes, like these containers are all just pods. We all have to kind of be compliant to the sidecar model, and Virtual Kubelet allows you to do sidecars.
Cool. So far, those are the only questions we have. Again, if anyone has any questions, feel free to submit them to the Q&A tab at the bottom of the screen. Let's see if there's...
Go let my dog in. 1 second. He was like scratching at the door. I was like, I can't leave yet. Yeah, I'm back.
Okay, well, it looks like there aren't any more questions.
Okay.
So
cool.
That was a lot. Thanks for the presentation. And just thank you everyone for joining us. The webinar recording and the slides will be online later today, and we're looking forward to seeing you all at a future CNCF webinar. Have a great day.
Thank you. Bye.